Yeah, welcome back to this channel. So by God's grace, we shall look at questions on motion methods, kinematics. The other time we explained in deep the concept of motion method. So now today we're going to proceed with the questions on motion method. Now the first question we have here says a boy cycled continuously through a distance of 2.0 kilometer in 6 minutes. Calculate the average speed. Okay, we asked to calculate the average speed. Now, how do we unravel that? A boy cycled continuously through a distance. So we've been given the distance to be 2.0 kilometer, which is 2 kilometers in 6 minutes. So the time t is 6 minutes. So we are asked to calculate the average speed. So we are meant to find the average speed, that is the unknown. Okay, an average speed is equal to the total distance of travel divided by the total time taken. Okay, so before we apply this formula, we have to do some conversions, okay, so that our answer will be in meters per second. So 2 kilometers to meters, we will do the conversion since 1 kilometer is equivalent to 1,000 meters. Therefore 2 kilometers will be equivalent to 2 multiplied by 1,000 meters, which is equal to 2,000 meters. So 2 kilometers is the same as 2,000 meters. Now, and also the time which has been given to be 6 minutes. All right, so and we know that 1 minute is equal to 60 seconds, right? So 6 minutes will be equal to 6 multiplied by 60. So, and that is 360 in seconds. So now, coming back to the formula to calculate the average speed. So the total distance is 2,000 meters divided by the time taken, which is 660 seconds. So this 0 can easily cancel out this. All right, so 2 can divide this, we have 100. Then 2 can divide this, we have 18. 2 can divide 18, we have 9. 2 can divide 100, we have 50. So our answer to that question is 50 all over 9 meters per second. That is in fraction, which is equivalent to 5.56 meters per second to 2 dp, 2 decimal places. All right, so that's how you get that. You unravel the question. So that was the first question, and then we have the second question, which says an Air Force jet flying with a speed of 315 meters per second went past an anti-craft gun. How far is the aircraft 7 seconds later when the gun was fired? All right, so now here we were given the speed of the aircraft. So the speed is 315 meters per second. Okay, So, and says how far is the aircraft. So now how far, what we meant to calculate there is the distance. Distance is how far an object traveled 7 seconds later. So the time is 7 seconds. Okay, time is 7 seconds. So how do we calculate distance? So to calculate distance, we have that distance with the symbol s is equal to speed with the symbol v multiplied by time with the symbol t, and the speed is 315 multiplied by 7. So when you multiply 315 by 7, you get 2,205 meters. Okay, so it's that's a multiple choice question. We have different options, and the correct answer is the answer in option D, 2,205 meters. All right, so we quickly move to the next question, which says a car traveled with a constant velocity of 55 kilometers per hour. So the velocity which is the same as speed, okay, but speed is a scalar while velocity is a vector quantity. So the velocity here excuse me, has been given to be 55 kilometers per hour for 30 seconds, and the time is 30 seconds. So it says, what distance does it cover in this time? So we asked to calculate the distance it covers in this time. Units of answer in meters. So they want our answer to be in meters. So we have to do conversions. So this 55 kilometers per hour should be converted to meters per second. So how do we convert from kilometer per hour to meters per second? So to convert from kilometer per hour to meters per second, so the number or the value you want to multiply, which was initially in kilometer per hour, you multiply by 1000. Okay, so that is kilometers to meters, then divided by 60 multiplied by 60, that is hour to seconds. So what do we have? So we say 55, which is the magnitude given here, multiplied by 1000, then divided by 60 multiplied by 60, that is 3600. all right, so 20 here can easily cancel out 20 there. So what we have left is 55 multiplied by 10, that is 550, divided by 36. So 560 divided 36, what you have is 15.28 meters per seconds. Okay, that's in decimal, this in fraction. So 15.28 in 2 decimal place. Now you have easily converted your velocity in kilometer per hour to velocity in meters per second. So which means velocity 55 kilometers per hour is equivalent to 15.28 meters per second. So now here you are asked to calculate the distance, and we know that distance is the product of velocity multiplied by time. So the velocity is 15.28, which has been converted. All right, so 15.28, then multiply by time. The time is 30 seconds. All right, so now when you multiply 15.28 by 30, so what you will have as your answer is 458.4 meters as the distance covered during the 30 seconds. So that marks the third question, and we quickly move to the fourth question, which says a body starts from rest and accelerates uniformly at the rate of 5 meters per second squared. So the body starts from rest, and we learn in the concept and the content in the previous video that when a body starts from rest, its initial velocity with the symbol u will be 0. Okay, and the body starts from rest, initial velocity will be 0, and accelerate uniformly at the rate of 5 meters per second squared. So the acceleration is 5 meters, per second squared, until it attains a velocity of 25 meters per second. So now the final velocity is 25 meters per second. Then you have to calculate the time taken to attain this velocity. So what is the time taken to attain this velocity? So now we quickly, check the 4 of the equation of linear motion that we would be able to apply these two. So we have one of the equation that say v equals u plus at, and then we have the second equation of linear motion that says v equals u square, plus 2as, and then we have a third one that say s equals ut, plus 1 all over 2 at square, and we have a third one that says v plus u all over 2, then multiply by time. Okay, so you look at the one of these, whichever one you will have these parameters, then you use. So there is velocity here, final velocity, initial velocity, acceleration, and then time. So the first equation will be the proper one to use. So you make use of the first equation. So v is equals u plus at. So we want is the time. So the final velocity is 25, equal to initial velocity is 0. You put that there, plus the acceleration is 5 multiplied by time that we meant to look for. All right, so 25 will be equal to 5 multiplied by t, 5t plus 0, that is 5t. Then you can divide both sides by 5. Okay, so this can easily cancel out this. 5 here is 1 and 5 here is 5. So the time, okay, to attain the velocity, which is the 25 meters per second velocity, is 5 seconds. So the time to attain that velocity is 5 seconds. All right, so we use the first equation there. So we quickly move to the next question, and the question says a train has an initial velocity of 44 meters per second. The train has an initial velocity, okay, so the initial velocity is 44 meters per second. So which means it's not starting from rest for this case. All right, and an acceleration of minus 4 meters per second square. So it has an acceleration of minus 4 meters per second square. That's deceleration, negative acceleration. Its velocity after 10 seconds, that is the final velocity now you are asked to look for after the time 10 seconds, okay, is what? So what will be the final velocity? So you have the parameters as well, and you use the equation that says v, equals u plus at. So the final velocity unknown, that's what we meant to know. The initial velocity is 44 plus acceleration is minus 4 multiplied by time, which is 10. So V will be equal to 44, plus minus 4 times 10, that is minus 40. So final velocity equals 44 plus multiplied by minus is minus 44 minus 40. Okay, so the final velocity will be equal to 4 meters per second. All right, so quick one into the next question, which says if a car starts from rest, so which means the initial velocity is 0 in this case because it's starting from rest, and move with a uniform acceleration of 10 meters per second. So the acceleration is 10 meters per second. Okay, you write that as A, rather 10 meters per second square, rather. Okay, so for 10 seconds, so the time is 10 seconds. The distance, okay, it covers the distance, question mark, in the last 1 second of motion. The distance it covers is the last 1 second of motion. So the distance it will cover in the last 1 second of motion, that is the last one, the total time, the time for that, distance is 10 seconds. Okay, but they said that this in the last 1 second, that will be the 9th and the 10th question. So that is the 10th seconds minus the distance for the 10 seconds. Okay, sorry, the distance between the 10 seconds and the distance of the 9th seconds. So we have to calculate distance at 10 seconds and distance at 9 seconds separately. So first, distance at 10 seconds. Now, which of the equation of motion has this? So is the equation that says ut plus 1 all over 2 at squared. All right, so the initial velocity is 0, so everything we have here would be 0 because 0 multiplied by 10, that is 0. So we reduce the equation to 1 all over 2 at squared, and which is 1 all over 2 multiplied by the acceleration. Acceleration is 10 multiplied by time. Time is 10. Then squared. All right, so 2 here is 1, 2 here is 5. 5 multiplied by 10 square, that is 500. So the distance at time 10 seconds is 500 meters. Then you will quickly find the distance at 9 seconds. So distance at 9 seconds, we know the initial velocity is 0 multiplied by 9, that's 0. So the equation will be reduced to 1 all over 2 at squared. Here the time is going to be 9. So therefore we have 1 all over 2 multiplied by acceleration still remain 10 multiplied by time now is 9, okay, squared. So 2 here is 1, 2 in 10, that's 5. That will be 5 multiplied by 9 times 9 is 81. So 5 multiplied by 81, that is 405 meters. So the distance, okay, during the last 1 second, which is equal to the difference between the distance in the 10 seconds and the distance in the 9th seconds. So that will be the distance in the 10 seconds is 500 minus the distance in the 9 seconds is 405. So the distance, covered in the last 1 second will therefore be 95 meters. Okay, 95 meters. So we have that as the first option in there. All right. However, we have an alternative method for solving this. We have an alternative method for solving this. You can actually say, given all the parameters you have here, and use your formula, which says S equals 1 all over 2 at squared. Don't forget the initial velocity is 0. When you multiply it with time, you get 0. So then you will have this left. So that will be 1 all over 2 multiplied by the acceleration, which is 10. Then multiply by the time. The time is going to be, 10 squared minus 9 squared. Okay, so that will now be 1 all over 2. Okay, you can cut 2 here is 1, 2 here is 5. So you have 5 multiplied by 100 minus 81. Okay, 100 minus 81. So when you do that, you will be left with 5 multiplied by 19. All right, so multiply that and tell me what your answer is. So now I leave you with that. You can pause the video and complete that. So you should get an answer which is also 95. Now, in this next question, we have a body starts from rest and move with uniform acceleration of 6 meters per second square. What distance does it cover in the third second? Okay, we have the multiple choice question in there. So now what distance does it cover? A body starts from rest, so which means the initial velocity is 0. Okay, and moves with a uniform acceleration. So the acceleration is 6 meters per second square. So what distance does it cover in 30 seconds? Now the distance it covers in the 30 seconds, that is the 30 seconds and the second to the last seconds, which is the second and the third seconds. So the distance it covers in the 30 seconds, between the 30 seconds and the second, the second to the last seconds, so is what we are meant to look at. So we have to look at the distance when the time is 3 seconds and the distance when the time is 2 seconds, and we subtract the 2. So the equation of motion that we're going to look is the equation that says S equals to ut plus 1 all over 2 at squared. All right, but meanwhile, because the initial velocity is 0, 0 multiplied by t, so that's going to cancel out. So we will be left with S equals 1 all over 2 at squared. So the time at 3 and then the time at 2. So to use the shortest method, we have 1 all over 2 multiplied by the acceleration, which is given as 6. Then multiply by the 2 times there, we have 3. Okay, square minus 2 square. Please, it is never 3 minus 2 then square outside. No, this is not it. Okay, but rather 3 having its own square and then 2 having its own square separately. So 2 here we give us 1 and 2 here is 3. So we are left with 3 into the bracket of 9 minus 4. Okay, so 9 minus 4, that is 5. So 3 multiplied by 5. Okay, so the distance it's covered in the 30 seconds will be 15 meters. As simple as that. And you can use the other method which we apply here. Okay, you can use this long method to check. You will still have the same answer. Okay, and that answer, the answer to the question, is found in the first option, option A. So we move to the next question, And the question says, a body accelerates uniformly from rest. So don't forget, whenever a body accelerates from rest, starts uniformly from rest, initial velocity will be 0 meter per second at the rate of 3 meter per second square. So the acceleration has been given to be 3 meters per second square for 8 seconds. So the time is 8 seconds. So you're asked to calculate the distance covered by the body during this acceleration. So the distance covered by the body during the acceleration we want to calculate. So using the relationship that says s equals 1 all over 2 at squared. So we didn't put ut because initial velocity is 0. So s will therefore be equal to 1 divided by 2. Acceleration is 3 multiplied by 8, squared. Alright, so we have s equals 1 all over 2 times 3 multiplied by 64. 2 here is 1 and 2 here is 32. So the distance will be 3 multiplied by 32, and the distance covered by the body during the acceleration is 96 meters. Okay, quick one. We have the next question, which says a particle starts from rest. Whenever a particle is starting from rest, the initial velocity is always 0 and move with a constant acceleration of 0.5 meters per second square. When acceleration is constant, final velocity will also eventually be 0. But meanwhile, the question says calculate the time taken by the particle to cover a distance, to cover a distance of 25 meters. So the time taken by the particle to cover a distance of 25 meters is what we would have to calculate here. So the initial velocity is 0. So use your equation that says 1 all over 2 at squared. So which is equals 1 all over 2 multiply by acceleration, which is 0.5 multiply by, we want to get the distance. So multiply by t squared. So equal to the distance. The distance is 25. Let me write it in a more simpler way. So the distance is 25 meters. Okay, that is 25 equal to 1 all over 2 times acceleration is 0.5 times t squared. What we want to get is the t squared. On cross multiplication, we have 2 multiplied by 25. Okay, that is 50. You cross multiply. 50 will now be equal to 0.5 t squared. So you divide both sides by 0.5 by 0.5. So this cancel out this. So 50 divided by 0.5, that is 100. Okay, equal to t squared. So you can now square root both sides. Square root of 100 and then square root of t squared. Square root, we cancel our square. Then you have t equal to the square root of 100. And the square root of 100 is 10. That is 10 seconds. Alright, as the answer. Okay, so we have another question. Says, how far will a body move in 4 seconds? How far? So what are you asked to calculate when they say how far? That is distance, because distance is defined as how far an object moves. So how far, we want to calculate the distance. A body moves in 4 seconds. The time is 4 seconds. If uniformly accelerated from rest, Okay, initial velocity is 0 at the rate of 2 meters per second square. So acceleration is 2 meters per second square. Still using the equation, which is 1 all over 2 at square. Alright, so that is 1 all over 2 times acceleration, which is 2, multiply by 4 square. So 2 can easily cancel out 2, and 4 square is 16. So the distance is 16 meters. That is how far. Alright, so if you have any question, you can send your questions to the number on the screen. Okay,